The angle which a chord sustains at the center of a circle is twice that which it sustains at the circumference of that same circle. This is the second theorem of circle geometry. Hello everyone, welcome to our video for today. In our video today, we are going to analyze the second theorem of circle geometry, and today we are going to analyze that with examples. If you are new to this channel, don't forget to hit the subscribe button and give this video a thumbs up. Also alert the bell icon so that you can get our content once they are uploaded. In today's video, we are going to consider the theorem 2 of circle geometry, the circle theorem. We have discussed the first theorem, and then we are going to look at the second theorem. And the second theorem states that the angle which our chord sustains at the center is twice that it sustains at the circumference of the circle. Now we're going to analyze this in three various ways. So we are not going to prove it, because in your examinations you don't need the proving, but we are going to show you examples on how you can consolidate your knowledge on how to solve the second theorem. Now let's get started. So the theorem states that the angle which an arc sustains at the center is equal to 2 times angle at what? At circumference. That is how I put it. That is how I put the theorem. Now this theorem can be exemplified in three ways, and these are the three ways in which you can see your questions in the exam hall. Now when we have a circle, let's assume the first way, this is the center of the circle. Now every angle, as I've explained in my introductory video of the theorem, circle theorem, angles or a chord of a circle can sustain an angle at the center of the circle or at the circumference of the circle. So this theorem says the angle which an arc or a chord sustains at the center is 2 times that it sustains at the circumference. Now when we have a chord and the chord sustains an angle at the center, definitely it will also sustain an angle at the circumference. Now how do we know that? Let's assume we'll have a chord. This is not necessary, we'll just assume it. So we'll have a chord. This chord can sustain an angle at the center. It can also sustain an angle at the what? At the circumference, which is what we want to discuss about. It can also sustain an angle at the what? At the circumference. So this is the angle at the center. So if the arc sustains an angle at the center, this angle can be angle here or the reflect angle, as I said in my previous video. Now when an arc sustains an angle at the center, this theorem is telling you that the angle it sustains at the center is equal to 2 times the angle it sustains at the what? Circumference. So if this angle here is x, angle at the center is equal to 2 times angle at the circumference. Now when we look at the angle at the circumference, if the angle at the circumference is x, so that means the angle at the center will be 2 times x. Now remember, this arc, this is the point this angle will sustain, right? Remember the theorem, it says the arc, it says the angle which a chord sustained at the center is equal to 2 times the angle it sustains at the circumference. So this angle will sustain this angle, and then if we have extend this part of the chord, this angle at the circumference, if it is y, this other part will be what? 2y. and that is what that point is, because this is the angle of this point at the circumference or at the center, while this one subtends this angle at this at this point. Now this is one of the drawing you can see in your exams. In your exams you can equally see a drawing like this. You can equally see a drawing like this where you have a chord, and you find out that this chord sustains an angle at the circumference. And since this chord sustains an angle at the circumference, it will also be extended to a point at the center of the circle, which is what? Which is 0. So this angle and this angle is what actually we are looking for. So if you look at this angle, if angle at the circumference is s, then angle at the center is equal to 2x. Now if we want to find out this, we can also extend this, and if we extend this, we'll have an angle here, which is y. This other part will now become 2y. So it either becomes like this or it becomes like this. So it either goes this way or it goes this way. Or better still yet, your question can come this way. They can give you the chord, this other part, and then they will tell you that this is the center of the circle. This chord sustains this part, this one is more confusing because you don't know where sustains where. This is one of the angle and this is another angle. Now this is the part on the circumference, why this is what? 2x. So this is the part, the chord. This is the part it sustains at the at the center of the circle, and this is the point the chord sustained at the circumference of the circle. Now I want you to take note of these three aspects. That's exactly how the question might come up, and then you see the question in the exam. So whichever way you are given, just make sure that you are not confused as the question goes. Now let's look at one simple example. This simple example is going to show us how to solve question on this second theorem. Now the first example says, given the figure below, find the value of y, z, and x. Now consider this figure very, very well. We are asked to find z, we are asked to find y, and we are asked to find x. Now you come to see that this angle S subtends this, is this, why this goes with what? With this is the angle at the center of this what? Of this point at the circumference. So we are going to consider the value of x first. To consider the value of x, we are going to find out that we will use the first rule, that the value, the angle, remember the second theorem, the angle which an chord sustains at the center is 2 times that it sustains at the circumference. So angle at the center, the angle at the center, we'll call it what? Angle what? Angle at the circumference is equal to what? Angle A, B, C is equal to 2 times angle what? Angle A, O, C. Because this is the center of the circle. So angle at the circumference is equal to 2 times angle at the center. The angle which a chord sustains at the center is equal to 2 times that it sustains at the circumference. So if that is that, we can now look at our angle 119 degree to be equal to 2 times x. So our x is equal to what? Our x will be equal to 2 times 119 degree, and that will be equal to 2 times 119 degree. If you point your calculator, you are going to have 238 what degree. So our x is equal to 238 degree. Now the reason will always be stated. Don't forget that angle at the center equal 2 times angle at what? Circumference. So having gotten that, we've gotten the value of y. The next thing we need to look for is the value of y. Now to get the value of y, having gotten x, we need to look at the angle at the point. Now the angle at the point sums up to give you 360. So what does that tell us? If we want to get our value for y, our value for y will now be equal to y plus x equal to 360. Reason, angle at a what? At the point. That is why you should get to know all the formulas. You should get to know all the every theorems that has to do with what? With angles and line. So if we do that, we are going to have our y plus 238 to be equal to 360 degrees. So our y will be equal to 360 degree minus 238. And so our y will be equal to 360 degree minus 238 will give us 122 degree. And that is that. Now, having gotten the value of y, we will now finally analyze the value for z. Now the value for z, we have seen that the angle at the center is equal to 2 times the angle at the circumference. So the angle at the center, y, is equal to 2 times the angle at the circumference. The reason is well stated. Angle at center equal to 2 times angle at circumference. So the angle at the circumference is z, and the angle at the center is y. So y will be equal to 2 times what? 2 times z. So what did we get as the value of y? We got 122 degree equal to 2 times z. So that means our z will now be equal to 122 degree divided by what? 2. So our angle z will now give us what? Our angle z will give us 122 divided by 2. 2 divide here will give us 6, and 2 here will give us what? Will give us 1. So this will give us 61 what? Degree. So we've gotten the total angle, we've gotten our x to be equal to 238 degree, we've gotten our y to be equal to 122 degree, and our z to be equal to 61 what? 61 degrees. So you see that the angle at the center 2 is greater than the angle at the circumference, because angle at the center is what? 2 times the angle at the circumference. Now we've come to realize that the angle at the center is equal to the 2 times the angle at the circumference. That is exactly what the theorem explains. Now let's analyze the second question. This is the final question that will help us consolidate our knowledge on Theorem 2. The second question says, given the figure below, find the value of angle RTS. Now, when you are given angle RTS, That means this is the angle you are looking for, which is this what? Which is this angle. Now remember the circle theorem too. The theorem says the angle which a chord subtends at the center is 2 times angle it subtends at the circumference. But then we don't know what the angle it subtends at the center is, but we are given what the value of that reflex angle is. Remember, when a chord does subtends an angle at the center, it forms 2 angles. One, the reflex angle, and the other 2 is the angle which is what? Which is an obtuse angle. Now, any of such angle it can either be an acute angle or an obtuse angle. So any of these angles, we need to find the value of x before we can find the angle which it subtends at the circumference. So remember that the angle which a chord subtends at the center, x, is equal to 2 times the angle it subtends at the what? At the circumference. So we are going to find this value of x. And at this value of x, to find this value of x, here we have angle at the point. And remember, angle at the point is equal to 360. So we can see that our x plus 264 degree is equal to 360. The sum of angles at the point, that's the reason, angle at the point sum up to give what? To give 360 degree. Angle at the point is equal to what? 360 degrees. So from here, our x will be equal to 360 degree minus 264. So our x is equal to, that our x will give us 90 what? Our x will give us 96. 10 minus 4 will give us 6. Then this 96, that's what it will give us. So we see, we'll find the value of x. Now remember the circle theorem. Some angle at the center is equal to 2 times angle at the circumference. So if x is what? S is equal to 2 times what? Angle at the center, which is angle t. So if this is 96, this will be equal to 2 times the angle at the center, which is angle t. So our angle t now will now be equal to 96 divided by what? By 2. So our angle t will be equal to 96 divided by 2, and 96 divided by 2, this will give us 4, and this will give us what? 8. So that will give you what? 48. So the angle it subtends at this point is what? 48 degree. Perfect and very good. So you see, this is how you solve questions when you are giving question on the second theorem of the circle theorem. You like this video, this is the best we can get for you. If you like this video, give this video a thumbs up, and don't forget to try subsequent questions so as to consolidate your knowledge on this topic. Give this video a thumbs up and subscribe to this channel so that you can get our subsequent videos once they are published. Thanks so much for watching.